2021। ध्यान से नेक्स्ट क्वेश्चन देखिए
सर ये
अरे
भी था।
सर
ये भी तो पूछा था।
पहले बता देते
सर इसके डायमेंशंस ही नहीं पते थे सर, ये इलेक्ट्रिक फील्ड सबके।
अरे कुछ भी ब्रैकेट में इसीलिए हम लोगों ने
दिया था
ब्रैकेट में
दिया था।
एरिया पर यूनिट टाइम इज पॉइंटिंग वेक्टर। This question would have come except for the fact that there is an impulse in this horizontal impulse. Because of that, this question didn't come. If not, this would also have come. Implies next major test, this question will be coming as one of the STEM questions.
थैंक यू सर।
थैंक यू
सर आप बता रहे हो?
हाँ बता रहा हूँ, तुमसे थोड़ी पूछ कर मेजर पेपर बनाएंगे, बता रहा हूँ।
सर थैंक यू।
कुछ नहीं रहा। Right, this was paper 2.
पेपर 1 में that projectile question came, I remember.
हाँ सर, so
Now
सॉल्व भी
listen,
करना पड़ा आंसर।
paper 1 में there is a question on,
सर रे ऑप्टिक्स का था।
no, this is vernier caliper. Right, we were running short of space, number of questions could not be accommodated, hence this does not come in this major test, implies it will come in
नेक्स्ट टाइम
मेजर टेस्ट।
ये क्वेश्चन कहीं पर देखा है आप लोगों ने?
पढ़ाया नहीं।
हाँ सर
ये वाला
सर ये किया है।
सर ये तो याद था।
मैंने याद कर लिया था, मतलब 20 सेकंड ही लगाए थे ये वाला क्वेश्चन करने में।
ये क्वेश्चन
ये भी।
देखा है कहीं पर?
ये वाला
ये
हाँ,
भी
सर।
क्वेश्चन था।
सर ये भी आया।
दोनों पार्ट्स आए थे, अच्छा था।
सर इसका तो पता था आंसर करेक्ट है जब
हाँ, सर।
सॉल्व हुआ था।
हाँ सर। सर ये भी आया था।
हाँ ये भी आया था सर, ये भी आया था।
क्वेश्चन करने में।
सर ऐसा सा मॉड्यूल में भी है, मतलब
सिमिलर है।
हाँ सर,
हाँ
similar।
उसी से हो जाता है।
फ्लूइड डायनामिक्स होने के बाद ये क्वेश्चन भी आएगा मेजर टेस्ट।
अरे सर थैंक यू सो मच सर।
टेस्ट के फ्लूइड डायनामिक्स के टॉपिक वाइज टेस्ट में क्वेश्चन आए।
ठीक है सर।
थैंक यू सर।
दिस वाज
2017 से भी था क्वेश्चन।
2020।
सर आप पेपर के पहले बोल देते ना, ये मतलब
सर ये सर सब P1 से
बहुत
आए थे।
अच्छा होता।
सर 1 साल से जान रहे हो आप हमें, मतलब थोड़ा कंपैशन।
सर ये लोग सीधा आएगा टॉपिक वाइज टेस्ट में।
तो ये कौन सा चैप्टर है?
थैंक यू सर।
फ्लूइड्स है।
थैंक
ये
यू सर।
क्वेश्चन देखा है आपने?
पेपर में आया था।
सर
पेपर्स देखे थे उन लोग को काफी क्वेश्चन आ गए।
सर ये
सर ऊपर भी था क्या कुछ तो? सर ऊपर भी था सर एक क्वेश्चन।
सर काइनेमैटिक्स का था।
सर इट सीम्ड लाइक देयर वाज सम x स्क्वायर का डिफरेंशिएशन समथिंग।
नहीं एक सेवा था एक क्वेश्चन।
ये हाँ वही
ये वाला
ये वाला।
हाँ।
तो ये सॉलिड क्वेश्चन था एकदम, बहुत सही
सर
मजा आ गया
सॉल्व करने
में।
सर, बहुत सही
क्वेश्चन
क्वेश्चन।
करके तो बहुत मजा आता है पेपर लिखने में।
Now this is on rotation which will come in the next topic wise test of rotation.
ओके
सर
सर।
बस करो सर।
Thank you, sir.
नहीं अभी चुप रह दो।
पेपर ही बोल रहा सर।
सर आप TWT के पहले ना पेपर भेज देना।
हाँ सर।
हाँ सर।
आंसर की मत
आपको
भेजना।
इतना तो मेहनत करना पड़ेगा अपनी तरफ से। जेई के वेबसाइट पर जाकर जो
ये आएगा हाइड्रोस्टैटिक्स के TWT में।
हाँ ये फ्लूइड्स का है, फ्लूइड्स और हाइड्रोडायनामिक्स।
Sir, that fluid mechanics track will you only be taking or will that be taken by ARP, sir?
Second try. Second.
Okay, sir.
सर तो आफ्टर
So you will take current, electricity and all of that, right?
Yeah. Now 2019 का पेपर देख लो. It was considered to be a very tough paper.
Yes sir.
This will
Sir,
come in the
sir.
next test, major test.
सर ये आ गया ऑलरेडी।
सर,
ऑलरेडी
किया हुआ है सर।
हाँ सर किया तो है। हाँ किया। सर ये कोई तो असाइनमेंट या किसी में तो था ये।
किया हुआ है क्वेश्चन।
We know how to solve it. That's the fact.
Yeah. ये नेक्स्ट मेजर टेस्ट में आएगा, ध्यान में रखो।
यस सर।
थैंक यू।
सर पूरा पेपर सॉल्व कर
Previous
दिया।
year MT के बजाय previous year
वेव ऑप्टिक्स के बाद ये क्वेश्चन गारंटी आएगा।
young.
Okay, okay.
young.
Sir, we are making a note.
ये
ये
देखा
Oh,
है
अरे
इसका आंसर
भाई।
फोर था
ये सब
इसका आंसर पता था
सेम ही था
ठीक है ये
एंगेज
क्वेश्चन
55
का आंसर पता था सर
This question was quite easy. Listen to me.
यस सर
Vertical
Sir,
displacement
displacement
तो
by
है
total
नहीं इस
time.
क्वेश्चन में, सिर्फ हॉरिजॉन्टल डिस्प्लेसमेंट है।
हाँ
तो
सर,
हॉरिजॉन्टल रेंज कैलकुलेट करने के लिए इसमें कोलिजन्स का कोई कॉन्सेप्ट यूज नहीं होता है,
yes.
because every time it collides, its velocity has already been given that it will decrease by r. So range, add up r1 plus r2 plus r3 up to r infinity.
GP.
Time of flight, add up, divide both, you get the average velocity. This is kinematics. This has got nothing to do with collisions. It would have been a problem of collisions if they give you the coefficient of restitution and then they don't give you u naught by alpha. They
Yes.
gave you u naught by alpha, so it is from kinematics. Every time after collision, what will be the velocity is given. All you have to do is resolve in the horizontal and vertical direction. You need the vertical velocity for time of flight, horizontal velocity for range. There is no concept of collisions or conservation of momentum in this question.
सर ये इंटीजर में था ना सर, तो
हाँ,
मैंने
सर,
देखा
इसका आंसर
0.8
4
है, तो मैं तुक्का मार दिया कि 4 होगा आंसर। 4 ही था आंसर।
ये क्वेश्चन भी था
ये भी था,
सर ये easy था।
ये भी देखा हुआ है सर।
तो इतने क्वेश्चन थे कि जब सिर्फ रिवाइज करके पेपर आके तो भी अच्छे मार्क्स आते
So
बोलना
now you
चाहिए था
know
पेपर
how
के
to
पहले।
prepare for your MT.
यस
Yes,
सर समझ
yes.
में आ गया
Sir, we got it.
क्यों सर
So now you actually know how to prepare for your
Yes,
MT.
sir, done.
So
Good.
can you see mains
Each one of you 5 years down the lane, $5 मेरे हिसाब में लिख लो।
$500
सर $5 क्यों सर? 5 बिटकॉइन दे देंगे आपको।
अरे भाई सब बनाएंगे ना छापेंगे इतना पैसा हम
अब listen.
सर
भी टैक्सेशन हो गया
सर
30%।
सर आप मेंस का
बजट
पेपर
में है ना
एक बार
30%
एक डाउट
टैक्सेशन
था
होता है
मेंस के पेपर में।
ARP सर के साथ कर लेंगे ना डिस्कस।
हाँ
अरे
सर,
हाँ,
शाम को
सर,
डाउट
पेपर
लेक्चर
Mains
है।
का पेपर doubt lecture में discuss mains and 3 things I'll do for the next 3-4 lectures. Last half an hour I'll take doubts because conservation of momentum का assignment का 1 or 2 problems are left over I believe. Booklet का left over है. So last half an hour I will give for doubts for the next 3-4 lectures. So that piecemeal we'll be able to
खत्म
complete.
कर दो ना डाउट।
Pardon?
सर सेंटर ऑफ सर कोलिजन्स का आगे डाउट कर लोगे आप होल डे मतलब होल लेक्चर वी कैन डू डाउट्स ना
हाँ सर नेक्स्ट क्लास से
सर
start
नेक्स्ट क्लास से वी कैन
rotation।
स्टार्ट रोटेशन
नहीं, there is a reason for it. Many of them have not completed collisions and conservation of momentum from booklet or the assignment.
ओके सर
सर हाँ
I
सर
am
सब
actually trying to buy time for them for reasons like this. For you in all the topics now, all the subjects, heavy topics are going.
यस सर
So I am trying to buy time because the chapter conservation of momentum is important. जिन बच्चों का भी वो pending है, this is the last chance they are having to complete it. Thereafter you will not get time. So from my side, I am doing my best. Last half an hour, if I discuss the doubts, you will keep in touch with the topic as well. And people who have not completed will get time to complete it as well. So both ways it will help them out.
So today also you'll be taking doubts, right? Last
No.
half.
Am I speaking French till now? या अंग्रेजी में बोल रहा हूँ क्या?
So sorry.
Next 3-4 lecture.
क्या जो समझाया उसका उल्टा बोल के you will say isn't it? What's wrong?
So I thought today also you'll be taking.
No,
Doubts.
today also last half an hour I'll take the doubts. Right? Mechanics में officially the last chapter and the largest chapter. Right?
रैपिड टेस्ट लग रहा है।
Pardon?
So can you repeat?
Mechanics में effectively the last chapter and the largest chapter.
सर
Yes, sir.
अप्रोक्सीमेटली कितना लेक्चर्स लगेगा?
हाँ सर.
Somebody log on to the YouTube and see 13 या 14 lectures है शायद.
और उतना भी लंबा नहीं है,
हाँ,
काइनेमेटिक्स
sir.
होगा 20 लेक्चर्स.
Just log on to
But slow
YouTube and
starting,
see rotational dynamics कितना lectures है.
सर
26
रिगार्डलेस
था
क्लास
लास्ट
जय माता दी के साथ
सीनियर्स का.
स्टार्ट करते हैं.
Seniors का कितना?
26 था 2022 वाला का देखा था.
हाँ नहीं, seniors का lectures were 1.5 hours.
okay sir.
Seniors का lectures
Around
were
19
1.5
18.
hours.
Yeah.
Right. So it
Sir,
will
16, 17, 8.
18 to 19.
effectively.
सर ये चैप्टर थोड़ा ऑफलाइन में भी होगा सर थोड़ा.
हाँ सर
No.
ऑफलाइन का भी होने वाला है.
Offline में partly doubts we will take, so on and so forth. It will be piecemeal wise, but continuity will be maintained. Now listen. Basically, till now, every object for you was a point object. Wherever you apply the force, till now, whenever you took this to be the center, you are applying the force here. Acceleration of center of mass is F divided by M. It did not matter for me where you apply the force. Wherever you apply the force, center of mass acceleration was the same. That even now will not change. You had a question in your booklet exercise 1 as well as assignment sheet. Where should I apply a force? At what height? Acceleration of center of mass will be F by M. Center of mass acceleration will not change, but the height at which I apply the force will change my alpha. It will change my angular acceleration, which was not touched in conservation of momentum. In particle dynamics, till now you were calculating only acceleration of center of mass. Here you will start taking alpha as well, angular acceleration. Now consider this. First point, when you are defining parameters, omega will be d theta by dt, radians per second. Alpha is d omega by dt or d2 theta by dt square radians per second square. Omega is omega naught plus alpha t. Omega square is omega naught square plus 2 alpha theta. Theta is omega naught t plus half alpha t. Something that we imported from circular motion, which will be true even in rotational dynamics for a rigid body. Rate of change of angular displacement is angular velocity. Rate of change of angular velocity is angular acceleration. Officially, anti-clockwise direction will be perpendicularly out of the board. Clockwise will be perpendicularly into the board. I'll show you that. First of all, take it down till here.
Yes, sir, done. 1 more minute, please.
क्लास का अटेंडेंस भी एकदम हाई है आज के दिन।
सर ये 3-4 लेक्चर के बाद सर कम होते जाएगा।
हो गया सर।
सर
सर,
5 सेकंड। हाँ सर, हो गया सर।
सर खाली बोलना था कि कुछ मंत्र है कि ये चैप्टर इजीली आ जाए प्लीज।
बड़ा आसान हो जाएगा, अटेंड करते जाओ लेक्चर। मेकिंग इट इजी इज माय जॉब, बस अटेंड करो। Now listen, this is a rigid body theorem. Angular velocity of the body with respect to any point on the body will be the same. Angular velocity of body with respect to rigid body with respect to any point of the body will be the same. क्या बोलना चाहते हैं यार आप? You're standing on earth. Let's take a simple example. Something which you can correlate. You are standing on earth. You are in Mumbai. What is the time period of the day?
24
12 hours day and 12 hours night.
So angular velocity of earth as measured by you will be such that time taken for one complete revolution is 24 hours. Somebody is on the other side of the globe in US. Will he report the same time period?
No,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Somebody says no.
Sorry,
Somebody
sir.
says
Yes,
Yes,
sir.
sir. He'll report the same time period.
wherever you are standing on earth, go and stand exactly on the north pole of earth, you will take 24 hours to complete it. With respect to any point on earth, wherever you stand on earth, the time period of earth is 24 hours.
Yes, sir.
So angular velocity will be the same.
Yes, sir.
Why does it be the same? Have a look at it. I stretch my hand and I turn my hand this way. There is an ant on my shirt here and there is an ant on my wrist here. I turned by 90 degrees. Will both of them report the same angular displacement?
Yes, sir.
Yes, sir. Yes.
What did you say? We cannot hear.
In the same time,
Yes, sir.
both the ant here and the ant on my wrist, both will report the same angular displacement in the same time. So they're actually reporting the same angular velocity.
Yes, sir.
Yes, sir.
So rigid body theorem says when a rigid body is rotating, the ant may be anywhere on my shirt, it will report the same angular velocity. Ant may be anywhere on my shirt, it will report the same angular velocity. So angular velocity of a body, rigid body, with respect to any point of the body will be the same. The mathematical dynamics of this I will come to at a much later stage. Right now, keep this in mind because we'll be using it.
So in circular motion, when there were sums like there are two stones attached to the same string and then you're rolling them around, we were unconsciously using this concept only, right, to find the velocity and stuff.
Two stones connected by a string, there, but it's not a rigid body. If it would have been a thin rod connecting, then 100% it's a rigid body. With a string जब connect करते हो, it's not a rigid body. But angular velocity will be the same because angular displacement is the same.
Yes.
Yes, sir.
Done, sir.
Firstly, we will learn how to take a torque equation. Torque will be represented by the symbol tau, Greek alphabet tau, if I'm right, TAU, right? This will be defined as moment of force. Moment of force. R cross F. Whenever you get moment of, it will be R cross that quantity. There will be a day in this chapter when we will define angular momentum as moment of momentum. So R cross moment. This is moment of force. R cross F. Torque is R cross F. Let us learn how to take the torque equation. There is a particle on which there is a force is acting. This is R, this is origin. You can take the torque about the origin, you can take the torque about something else. All those parameters I'll come to in the third lecture. First, I'm learning how to take the torque equation. Torque about O is R cross F. This is theta. R cross F will be R F sine theta. If I put a mod, this will be R into F into sine theta. R sine theta into F. Do you agree with this?
Yes, sir.
Yes, sir.
Extend the line of action of the force. If this is theta, this is theta. This will be R sine theta. Extend the line of action of the force. Drop a perpendicular on it from the point about which you are taking the torque. Force into the perpendicular distance is the torque. Force into the perpendicular distance is the torque. Right? I repeat the logic. Magnitude of the torque. How do you do it? Extend. You on a body, you will calculate torque due to all forces. On a body, you will calculate the torque due to all the forces. So extend the line of action of the force. Drop a perpendicular on it from the point about which you are taking the torque. Force into the perpendicular distance is the torque. First point, extend line of action of force. Drop a perpendicular on the line from the point about which torque is being taken. Third step, magnitude of torque is this R perpendicular into F. What did you say? Extend the line of action of the force. Drop a perpendicular on that line from the point about which the torque is taken. Force into that perpendicular distance will be the torque. Is this point clear?
Yes,
sir.
Yes, sir.
Yes, sir.
Yes.
Now I should define if it is a clockwise torque or an anti-clockwise torque. Officially, R cross F, I will get perpendicularly into the board. Yes or no?
Yes, sir.
Yes, sir.
Perpendicularly into the board is clockwise. Perpendicularly out of the board is anti-clockwise.
Anti-clockwise.
The other way of looking at it, connect these both points by a rigid body. Which two points? Point at which the force is acting and the point about which you are taking the torque. Point at which the force is acting and the point about which you are taking the torque. Force into the perpendicular distance. If the body rotates in the clockwise direction, it's a clockwise torque. Let this point move in the direction of the force. If the body rotates in clockwise, it's a clockwise torque. If the body rotates in anti-clockwise, it's an anti-clockwise torque.
Yes, sir, I understand.
Yes, sir.
First, take it down till here.
Into the board is anti-clockwise.
Clockwise is into the board. R cross of D flow, you're getting into the board. It's clockwise, right? Perpendicularly out of the board is anti-clockwise. Clockwise, perpendicular into anti-clockwise, perpendicular outwards. Rotate your four fingers in the direction anti-clockwise, perpendicular outwards, clockwise, perpendicular in.
Sir,
Hmm.
sir, what is torque physically? Like, we know what's a force is and what.
What is force? Which produces linear acceleration.
Yes, sir.
Torque produces angular acceleration.
Okay, so it's a type of a force, let's say.
All forces contribute to torque. Force produces linear acceleration. Torque produces angular acceleration. It is the replacement of force in rotational dynamics.
Okay, sir, got it.
Can you make us visualize?
Torque visualize क्या करेंगे यार यही तो है R cross है. Making a body rotate as simple as it. Torque is making a body rotate. Force is making a body accelerate. Fair enough?
Yes, sir.
Torque is making a body rotate. Angular
Yes.
acceleration rather.
Done, sir.
So bottom line, remember, extend the line of action of the force. Drop a perpendicular on it from the point about which you are taking the torque. Force into the perpendicular distance with the torque. This makes it rotate. Connect this point and this point by a rigid body. Point about which you are taking the torque is fixed. Point at which force is acting is free to move in that direction. If the body rotates in clockwise, it's a clockwise torque. If it rotates in anti-clockwise, it is an anti-clockwise torque. Till here, everybody clear about it?
Yes, sir.
Yes,
sir.
We'll take an example to see how to calculate the torque. More than one example we will take. First of all, a very simple example. This is a thin rod held with the help of two strings. Tell me your convenient numbers capital M, shall I take 10 kg?
10 kg.
Yes, sir.
Yes, sir.
There is small m. This distance is 1 meter. This distance is 0.3 meters. Small m, if it is not placed here, T1 would have been equal to T2 by symmetry. But because you placed some weight here, T1 will be different when compared to T2.
Yes.
Yes, sir.
Yes, sir.
But system is
Yes,
in
sir.
equilibrium. Nothing is having angular acceleration. System is in
Equilibrium.
equilibrium. Equilibrium. Question asked is find T1 and T2. Now what will I do? First equation is quite simple. All forces in upward direction will be equal to forces in
Downward direction.
Let me take small m to be 5 kg. Capital M mass of the rod is 10 kg. I am assuming I have taken very good numbers. First equation is T1 plus T2 is 10 plus 5 into G. First equation, all of you clear with?
Yes,
Yes.
sir. Yes, sir.
Yes, sir.
All forces in upward direction are equal to forces in downward direction. Horizontal, there are no forces.
Yes, sir.
Yes, sir.
Horizontal, there are
No forces.
Now, rod is in equilibrium. Just as it doesn't have linear acceleration, it doesn't even have angular acceleration.
Yes, sir.
So net
Yes, sir.
total torque about center of mass will be 0. Net total force is 0 बोला आपने because acceleration of center of mass is 0. Net total torque also is 0 because it is in equilibrium.
Yes,
Now, how do I take the torque? Observe this. All forces acting on the body will produce a torque. You will have to take the torque due to all forces acting in the body. You cannot be selected.
Okay,
Right? Firstly, T1. Extend the line of action of T1 and drop a perpendicular on it from the center of mass. It will be T1 into 0.5 meters. Do you agree with this?
Yes,
Yes, sir.
Yes, sir.
I am taking clockwise positive. You can take anything. It's like telling you everything in the upward direction is positive, downwards is negative. What if I take upwards as negative, downwards as positive? Nothing will change. Everything will be fine. Just stick to that sign convention till the end of the problem. I am taking clockwise positive. What makes you think that this is clockwise? Connect these both points by rigid body. Point about which you are taking the torque is fixed. Point at which the force is acting is free to move in this direction. Is the body moving in clockwise?
Clockwise.
Yes.
sir.
Yes, sir.
Clockwise.
This is clockwise. I am taking it as positive.
Yes, sir. Yes, sir.
Small mg, this is 5g, into the perpendicular distance is 0.3.
Anti-clockwise.
All of you,
Anti-clockwise.
Yes, sir.
minus. I have taken clockwise positive, so anti-clockwise will be negative. Now, capital Mg, perpendicular distance is 0. Force is passing through that particular point. You drop a perpendicular on that, from that point, the perpendicular distance is 0. Are you trying to tell me n number of forces passing through this point will produce 0 torque about that point? Yes.
Yes.
Because the perpendicular distance is 0.
Zero.
Now T2 into this perpendicular distance, T2 into 0.5. Extend the line of action of T2 and drop a perpendicular on it from the point about which you are taking the torque.
Minus.
Anti-clockwise.
Anti-clockwise, negative.
Clockwise, negative. Net total torque should be 0. Torque due to T1, torque due to small mg, torque due to capital mg, torque due to T2. Clockwise I have taken positive, anti-clockwise I have taken negative. This becomes 0. T1 by 2 minus T2 by 2 is equal to 15. This is my second equation. Two equations and two variables. Will I be able to calculate T1 and T2?
Yes, sir.
Yes, sir.
Yes, sir.
So can you do the anti-clockwise direction for the 5G mass again? Okay, sir, understood.
Take it
So
down
for
to here and
capital
solve.
M, there is no perpendicular distance, right?
The perpendicular distance is 0 because that capital Mg is passing through the center of mass.
Yes, sir, got it.
If there is a force passing through a point, torque about that point will be 0 due to that force.
Okay, sir.
सर 10 स्टैंडर्ड के अच्छे पल याद आ रहे हैं.
Moment of force.
Yes, sir. You're balancing a ruler, find how much weight you have
और
to put.
0.5 is सर बहुत अच्छा था तभी.
There unknowingly you have taken the torque only on both sides, or
हाँ, sir,
maybe
you-
knowingly. Tenth ICSE board में ना?
Yes, sir, 10th ICSE.
Yes, sir.
सर आईजी में भी था.
आईजी में भी था सर.
To define that moment arm are perpendicular, I remember in schools they give you one quotation in the textbook. I think Archimedes or Aristotle's statement. Give me a very long rod, I can lift earth.
हाँ, yes, sir. Yes,
Sir,
sir.
था,
There
था,
are
lift,
हाँ,
lift,
sir.
sir.
Actually, उस पर बहुत चर्चा हुई थी. Long back, students used to drill my happiness off with that. Lifting earth is a meaningless statement actually. What he meant was the lever arm, which he wanted to explain. But it can be misinterpreted. Lifting earth does not make sense. What is the weight of earth?
Sir, zero, sir. There is no weight of
Zero.
the
Zero. Mass of earth may be huge, but weight of earth does not make sense. The force with which I am being pulled towards the center of the earth is my weight.
Yes.
Now, earth, just give me place to stand. This is sun. This is earth. Earth has a force this way. Vertical direction, there is no force. Give me a place to stand. I can lift earth with one single hand. I'll place my hand underneath earth and lift it. In that direction, there is no force. It's like remove gravity, I will lift Mount Everest with a single hand.
Yes, sir.
Remove gravity. Mount Everest, just give me sufficient space, I will lift Mount Everest. Right? To remove earth from sun's gravity, to pull it outwards, you will need a million Hercules. To pull this out of sun's gravity, radially outwards. Vertical direction, there is no force. Any one of us can lift it, provided you give me a place to stand. Based on that, students gave a very different argument. They said, what do you mean by lifting? Right? What do you mean by lifting? Lifting something this way. They said even this is called lifting. This is a stand with your hands upside down. Don't you think you are lifting earth? What is north, south, east, west? Only with respect to earth. Now, don't you think this man is lifting earth?
Yes, sir.
Yes,
So
sir.
whenever
Yes.
you stand with your hands down and legs up, you are actually lifting earth. So that
Yes.
statement was subjected to multiple arguments so many times. Give me sufficiently long rod, I can lift earth. Statement was to explain the moment arm are perpendicular. All this argument will lead us into.
嗯
different dynamics of that statement.
嗯
Right?
嗯
So whenever you stand with your hands upside down, don't you think this man is lifting earth?
Yes, sir.
What is north, south, east, west? Only with respect to earth. Now, don't you think this man is lifting earth?
सर सबसे हिलेरियस तो वो बोर्ड एग्जाम का वो एक क्वेश्चन था कि when you tie a stone to a string and then you whirl it in a circle, then what force acts on the hand? According to them, the answer is centrifugal force.
Hand per.
हाँ.
Sir, but the thing is, but there it was in 10th book also written it was a pseudo force, but then too they said that only.
सर नॉर्मल फोर्स लिखा है था हम लोग को तो.
Hey, you are whirling
हाँ,
it, right?
Yes, sir.
So tension is acting on you.
Exactly,
Yes,
sir.
sir.
There
Yes,
is
sir.
centrifugal force.
Sir, sir, the funny thing is 10th की book में लिखा था it is centrifugal force is a pseudo force. Then too they said it.
Centrifugal is a pseudo force.
Ah, sir. So it was written in 10th book also, but they still gave an answer as centrifugal force only.
I'm surprised.
Yes, sir, done.
Done, sir.
और कुछ ज्यादा ही जल्दी चला गया ये एक साल.
हाँ ना सर.
अगले साल और ज्यादा जल्दी चलेगा. This 1 year you think has gone very fast. You will see when your syllabus is over, you will realize we even didn't blink by then the syllabus is over. You will feel that fast.
सर विंक ऑफ आई में एक मंथ निकल गया 2020.
तो नया साल क्या
तो
पता ही नहीं चला.
No, listen. We are yet learning how to take the torque equation. I'll take the torque about point P. Draw all the forces acting on it. This is mg. This will be normal force n1. This will be normal force n2. For sure, this ladder will not be in equilibrium. For sure, the ladder will not be in equilibrium because there is no force to balance n2. I have taken smooth all throughout. So
Yes.
I'm not worried about the problem. Neither am I asking you if it is in equilibrium or not. I want to learn how to take a torque. Hence, my purpose is different. Now I want to take the torque about point P. Do you recollect in Newton's laws we told you how to take this normal force? If common area is not defined, normal force will be perpendicular to the surface at the point of contact. Normal force will be perpendicular to the surface at the point of contact. Newton's laws may be learned this. I hope you people remember.
Yes, sir.
Yes, sir.
Yes, sir.
Now, you are taking torque about point P. Can I take the torque about center of mass? You can. What are all the points about which you can take torque will be explained in the third lecture from now. Till then, you will blindly follow. I am taking torque about point P, take the torque about point P. I am taking about center of mass, take it about center of mass. Rules to take the torque about different points about which you are eligible to take the torque will be explained in the third lecture from now. Till then, follow me. Torque about point P. N1 will give me 0 torque. Yes or no?
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Mg. Extend the line of action of Mg and drop a perpendicular on it. Mg into L by 2 cos theta. Mg into this perpendicular distance is L by 2 cos theta.
Yes, sir. Yes, sir.
How did you decide a negative? Because it is anti-clockwise. Are you able
Yes,
to
sir.
see this anti-clockwise?
Yes, sir.
Now, third, extend the line of action of N2 and drop a perpendicular on it. What will be this perpendicular distance?
L sin
L
theta.
sin theta.
sin theta.
And this will give me clockwise.
Yes, sir.
Show you why it is clockwise. Point about which you are taking the torque is fixed. Point at which the force is acting is free to move in that direction. It's clockwise torque.
Yes, sir.
I don't want to rotate these bodies here. You're welcome. Take arc cross F. Arc cross F, you are getting perpendicularly inwards. Perpendicularly inwards is clockwise.
Yes.
Yes, sir.
Now I understood how to take the torque about a particular point.
Yes, sir.
Yes, sir.
I will take that same ladder example with friction here to calculate the equilibrium condition. Take it down till here.
Sir,
Huh.
so can you please tell again that why moment of end normal is 0?
Extend N1 and drop a perpendicular on it from P. What is the perpendicular distance?
0.
N1 into 0 will be 0. So if there is a force passing through a point, torque about that point due to that force will be 0. Center of the board.
Yes, sir.
Now, same problem I will take and I will introduce. By the way, here, one student in the previous lecture asked me, can I resolve mg? You are increasing your labor. I have no problem. You want to resolve mg, right? Have a look at this. Please do resolve. This is mg cos theta. This is mg sin theta. Do you agree with that?
Yes.
Yes. Yes, sir.
Now mg sin theta is passing through the point P. So torque due to mg sin theta is 0. Do you agree with that?
Yes.
Yes, sir.
Yes, sir.
Cos theta into L by 2. देख लो mg की वजह से वही टॉर्क लिखा है कि नहीं?
Yes, sir.
Sir.
Right? mg cos theta into the perpendicular distance is L by 2. Extend the line of action of mg cos theta. Drop a perpendicular. You will get mg cos theta into L by 2. mg का टॉर्क यही तो लिखे थे हमने.
Yes, sir.
Sir.
If somebody want to resolve a force, no, I want to take the result, and you're welcome. Either of the way you will get the same answer provided you do it correct. Now in this case, I'll take friction mu n1. What is the minimum value of mu for which the body will be in equilibrium? वो minimum value पूछा तो मैं maximum value of friction ले लूंगा, limiting value.
Yes, sir. Yes.
Now, for the body to be in equilibrium, N2 should be equal to mu N1. First equation, forces in the horizontal direction should balance out each other. Similarly, forces in the vertical direction, mg is equal to N1. Both the translational dynamic equations I am done with. Yes or no?
Yes.
Yes, sir.
Now, torque, the body should be in equilibrium. It's not rotating. So torque about the point P should be 0. Why are you only selecting point P? Temporarily do it the way I'm telling you. You will have the discretion to select a different point in another 2 lectures. Torque about point P should be 0. Torque about point P due to N1 is
0.
N1 is
0.
There are only 2 forces which are producing a torque. This will be clockwise, this will be anti-clockwise. Are you able to visualize that?
Yes.
Yes.
So that means mg into L by 2 cos theta. N2 into perpendicular distances L sin theta. This is anti-clockwise, this is clockwise, these both should be equal and opposite. Further ladder to be in equilibrium.
Yes, sir.
Yes, sir.
So here we have to find.
They'll arrange for the vehicles. My point was to learn how to take the torque. Technically, they'll keep asking you if there's a ladder, to what height can a man climb? So you will add his torque as well. Add that one more force along with mg. You have that problem in your booklets, so you will be doing it.
So, so now we are again at par with flagship, right?
Yeah.
हो गया
Sir, 30 seconds more. Done.
Now, a very important application from the torque equation only. We have learned how to take the torque. Do you people remember in circular motion the maximum speed with which a vehicle can take a turn?
Yes, sir. Tan
Yes, sir.
theta is equal
Yes,
to
sir.
V
Root
square by
RG.
RG.
V square by RG. Tan inverse of V square.
Root RG tan theta.
Root tan theta.
Horizontal
अरे हाँ.
road पर maximum speed with
अरे
which,
horizontal road पर sorry sir sorry.
You are new RG.
and अगर banked road है तभी भी आपका आंसर गलत है. Banked road पर tan theta is V square by RG is the velocity with which you should take a turn where you don't want to use friction. That is not V maximum.
Yes sir yes. Sir.
V maximum is when it's acting downwards. The friction is acting
When
down the
friction
slope.
will act downwards, component of friction and component of normal force together will provide the centripetal force.
Yes, sir.
I'm asking you V maximum for skidding. V maximum will be root over of mu RG.
yes
याद
sir.
आ रहा है?
हाँ सर सर
Yes,
भूल
sir.
गया था
टेस्ट लिया है 3 दिन पहले आप लोग रिवीजन भी किया है उसका
सर ये याद है
Yes, sir. याद है.
जल्दी जल्दी में भूल गया
There we have considered the vehicle to be a point object. We didn't consider the dimensions of the vehicle.
Yes,
We only
sir.
considered the vehicle will skid outwards. Vehicle can even topple.
Yes, sir.
Yes, sir.
Vehicle can even topple. Toppling condition. Toppling of a vehicle. Toppling of a vehicle. Right? This is a road going perpendicularly into the board. Road going perpendicularly into the board. Matlab, are you able to visualize this? You are
Yes,
seeing
sir.
this part. These are the inner wheels, these are the outer wheels. You are seeing the back part of the vehicle. Vehicle is going perpendicularly into the board. Are you able to visualize this?
Yes.
Yes. Yes, sir.
My thumb is the inner wheel, my forefinger is the outer wheel. Yes or no?
Yes, sir.
Yes.
Normal force on the inner wheel I will take as N1. Normal force on the outer wheel I take as N2. Mg will be acting downwards. H is the height of the center of mass from the ground. And 2a is the distance between the tires. 2a is the distance between the two tires, inner and outer. 2a, distance between the two tires, right? When the vehicle is turning, if the vehicle is toppling, which wheels do you think will take off from the ground? Inner wheels or outer?
Outer wheel.
Or outer.
Outer. Smart.
Outer wheel, so yes.
Or outer will.
So when it is turning, it should be outer only, no?
Listen, let us assume we don't know any physics. Let's use common sense.
Yes, sir.
Common sense is not very common among people. Are you aware of it?
Yes,
Yes,
sir.
sir.
Ironically.
Yes, sir.
This quotation is given by whom?
Mark Twain.
ACB.
ACP, sir.
ACP, sir.
नहीं पता शायद Mark Twain.
Sir, Shahrukh Khan. Sentence बस.
Sir,
जनरल नॉलेज ना ओके
जनरल नॉलेज दुनिया भर का होता है आपके पास. शाहरुख खान.
सर सारे नामों में से शाहरुख खान मतलब कैसे?
शाहरुख खान ही मिला तुम्हें बदनाम करने के लिए. Now listen. Firstly, keeping jokes apart, listen to me. How do you bank a road? Banking a road is lifting the outer side. What is banking a road? Lifting the outer side?
Yes, sir.
Yes, sir.
Sir.
Is taking a turn. If really there was a potential risk of the outer wheels taking off from the ground, now that you have lifted the outer side, 100% you are going to topple the vehicle. Agar सच्ची में outer wheels were to take off from the ground, vehicle is taking a turn this way. That means outer wheels, if they take off from the ground, the vehicle will turn inwards. If really that were true, now by banking the road, you are 100% going to topple the vehicle.
Yes, sir.
Yes, sir.
Banking a road saves your vehicle, it doesn't topple your vehicle. Matlab the risk is with inner wheels, not the outer wheels. Outer wheels will never take off from the ground. Speed picture देखा है आपने?
हाँ, sir.
Yes.
नहीं सर.
No, sir.
नहीं देखा है?
पर याद नहीं है सर, बहुत पहले देखा
सर
है।
स्पीड
इतना
सर
अच्छा
मूवी
movie
नहीं
है
देखा.
यार.
Sir, cars
सर
देखो.
नहीं देखते मूवी.
हाँ सर, याद है वो ट्रक के
Concept of
नीचे.
the movie is a bus is fit with a bomb. If the speed of the vehicle comes below 50, the bomb will explode. 50 kilometers per hour. 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 50 kilo So now their problem is maintaining a speed above 50. So the hero of the movie will ask the driver to turn the vehicle into the airport because of traffic hazards. The first time they have to take a turn, they show the inner wheels taking off from the ground very properly. अगर आप लोगों ने observe किया होगा, right? See the movie next time when you see, observe. The director took a lot of pain. You get to see Rajnikant walking, outer wheels will be flying many a times. The director didn't pay attention properly. Outer wheels will never take off from the ground. It's inner wheels which will take off from the ground.
टाइम सर कभी हुआ था ये सर अब पता है ड्यूरेशन
स्पीड का मूवी
हाँ सर 2 घंटे सर
स्पीड का मूवी में at what time will that scene come? This is what you're asking me?
Yes
Sir,
sir.
was it a climax?
तो देख के बताऊंगा, वो टाइमिंग मुझे थोड़ी याद है.
हाँ सर.
Now listen, you don't want the vehicle to topple. So force is, by the way, it's a horizontal road. So who provides the centripetal force?
Friction.
Friction.
mv square by r. Friction provides the centripetal force.
Yes.
Now forces in upward direction should be equal to forces in downward direction. First equation, are we clear about?
Yes.
Yes sir. Yes.
Now, friction provides the required centripetal force. I will call this the second equation. Third, vehicle should not topple. That means torque about center of mass should be 0. Torque about center of mass should be 0. Vehicle should not topple. So the rotating effect should be 0. So the torque should be 0. So far, so good. Yes or no?
Yes, sir.
Yes, sir.
mg is passing through the center of mass. Will it produce any torque?
No,
No, sir.
Sir.
One, this perpendicular distance is A. 2A is the distance between the tires. So distance from the center of mass till N1. N1 into A. Tell me if it is clockwise or anti-clockwise.
Clockwise.
Clockwise.
N2 into
Anti-clockwise.
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 N2 into A. Now one more force is left over, friction.
Yes,
mg will not produce any torque. It is passing through the center of mass. I'm okay. But friction, bhulna mat. Friction. Tell me if it is clockwise or anti-clockwise.
Clockwise.
Plus Fr into H should be 0. N1 is clockwise. N2 is anti-clockwise torque. Friction is giving me clockwise torque. Extend the line of action of the force. Drop a perpendicular on it from the point about which you are taking the torque. Here, I decided we take the torque about center of mass. Right? You will keep deciding every time. Wait for 2 lectures. You will also be able to decide the points about which you can take the torque. Now this will be N2 minus N1 is equal to mv square h by Ra. What have I done? I multiplied whole of the equation with a negative sign. Brought friction and h to the left side. Right? Or kept it there and brought these two to the left. N2 minus N1. Brought A to the denominator. Friction is mv square by R. I substituted. Are we okay with the simplification?
Yes, sir.
Yes, sir.
Yes, sir.
This is one equation. This is one equation. Add both of them. I will get N2 is mg by 2 plus mv square h by 2r. Subtract both of them. I will get mg by 2 minus mv square h by 2r. Can N2 ever become 0? Sum of two positive quantities can never be 0. Can N1 become 0?
Yes, it
Yes,
can.
sir.
N1 can become 0. So the inner wheels can take off from the ground. N1 becomes 0 means inner wheels are losing contact with the ground. When will N1 become 0? When mg by 2 is mv square h by 2ra. 2 and 2, m and m will go. Velocity maximum is rad by h. R is the radius, A is the distance between the tires, H is the height of the vehicle from the ground. R is the distance of the center from the vehicle. R is this particular distance, center of the circular track. A is the distance between the two tires, half the distance between the tires. H is the height of the vehicle. Formula 1 racing में कभी आपने ध्यान से देखा है, height of the vehicle will be very low. The driver's seat once upon a time was at 9 inches from the ground. They have made it 11 inches somewhere in 2010 as a precautionary measure. The lower part of the driver's seat will be at 12 inches from the ground. It will be brought down to such an extent that the driver is sitting in a cockpit type of a structure and the wheels will be at the same height.
Sir.
Height of the vehicle will be so low. Why is the height so low? Lesser the height, greater will be the velocity with which you take a turn.
So wheels are also further away.
इसलिए
So wheels are also a little further away.
Wheels also. He's in a tight cockpit type of a structure and the wheels are at that distance. Why? They want to increase A. Greater the velocity with which you can take a turn.
Yes, sir.
If ever you observed a loaded truck,
Yes, sir.
in any form of accident, it will be in a toppled condition.
Yes, sir.
Yes, sir.
Loaded truck in any form of an accident will be in a toppled condition. Why? Loaded truck may height of the center of mass cannot be brought down. It has gone up. So when the vehicle has to take a turn, he will make sure that he has to slow down. At high speeds, a loaded truck cannot take a turn. If it takes a turn, it will topple for sure. If you people know the history of four-wheelers in our country, there was a time when we had only Ambassador car and Maruti 800.
Yes, sir.
Maruti 800 देखा है आप लोगों ने कभी?
हाँ सर
हाँ, sir. था.
Yes, sir.
Yes, sir.
If you stand beside the vehicle, it will come to this height. It is a very short vehicle. The height is very low. To sit, you had to go down. To sit in that car, you had to go down. But then, any form of accident, it may be crumpled into pulp, but it will not be toppled because height is so low. Right?
Sir.
The first competitor which came for Maruti 800 in India was Hyundai. Hyundai Santro. Hyundai Santro ka, if you people have ever seen the first version of Hyundai Santro, it had a very awkward structure in the top, in the front, and a vehicle somewhere like this. It had a very awkward structure. And the brand ambassador for Hyundai Santro was Shah Rukh Khan. The concept of brand ambassador also then started off. He used to stand beside and show the height of the car. Sitting comfort was really good when compared to Maruti 800. But if ever there was an accident, it was also in the toppled condition. Tall boy model car. Small car for the Indian roads made sure that A will be lesser. Then H also should be lesser. For comfort, they increased the height of the vehicle and they didn't increase the distance between the two tires. So possible accidents of toppling were higher than Maruti. Maruti showroom, you go, everybody were well educated to inform the customers that, look, Hyundai has a toppling problem. So then Hyundai came up with Hyundai Santro. In Hyundai Santro, what they did was, they increased the weight of the chassis. Chassis, the weight they increased and they made this light. The upper body they started making it with a polymer structure. Even now, any of the cars, you climb on the car and hit with your hand, there will be a dent.
Yes.
The upper part of the car is made of light material, unless and until they are the so-called German make European cars, they'll be slightly harder, but even they will be like solid cars there. Now, what happened here is, Hyundai Santro came up with greater chassis weight and brought down the center of mass. Center of mass came down. They were happy. They started advertising about the stability, but they missed one important point. In India, the roads either have speed breakers or potholes of equal amplitude on both sides.
Yes, sir.
So on the speed breaker, when you are passing by, the lower chassis used to touch the speed brake if you are going at some speed. So again, that became a part of advertisement for the competitors. Then Hyundai again came up with Santro Zing, and then complete rectified model became i10. Hyundai came up with i10 where they made this compact. They decreased the weight of the upper part further, but at the same time increased the ground clearance for the vehicle. So then it became a tall hybrid structure of a tall boy model and a small car. Safest will always be a sedan, the dimensions of any sedan. Because
Yes, sir.
if you are increasing the height slightly for comfort, you should increase the distance between the tires as well. For an SUV, you increase the height, you have to increase the distance between the tires. You don't, toppling problems will rise. For a bus, the height is more. The width of the tires, the distance between the tires will be greater. Anytime you want to increase the height of the vehicle, you have to increase the distance between the tires.
So
Only then the stability ratio will be maintained.
so the double decker will be more dangerous than the single decker.
Double decker, there are strong speed limits established. Double decker will never generally go at a speed beyond a limit. Second, those Volvo buses which you see as a double decker are not actually double decker.
Yes, sir.
You added into
The
cars.
buses which you see in Mumbai, which go from Mumbai to Ahmedabad, they are not double decker. ऊपर जो luggage रखते हैं ना, वहाँ they put a berth for people to sleep. They are not double decker buses. Those double deckers which you see on the city roads have speed limits. They don't cross 45 kilometers per hour. हालांकि मुंबई रोड पे either way you cannot cross 45 kilometers per hour. कहाँ 60 kilometers पहुंच जाओगे? मुंबई के कौन सा एरिया में पहुंच? हाईवे पर भी नहीं पहुंच पाओगे 60 कभी-कभी. 60 टच किया तो बहुत ज्यादा. So this is the maximum speed with which you can take a turn, preventing toppling of the vehicle. And to prevent skidding, the speed that you should take a turn should be less than root over of mu rg.
Yeah.
Is that clear?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
So for
We
the
have learned
friction,
how to drive a car.
सर सुपर
Yes, sir.
कार
In
या सर जो रेस कार्स रहते हैं वो सर वो भी टॉपलिंग नहीं करती है सर, तो वो उसका रीजन क्या?
बोला ना F1 के कार.
मैं बोला ना सेंटर मार्क बहुत नीचे होता है.
Center of mass of the racing cars will be quite low. Because of turning, they don't topple. They topple because they collide with something or the other.
Yes, sir. Okay, sir. Got it.
But
So now,
possible toppling for that is very minimal because their height is much lower. Lesser the height, greater will be the velocity with which you can take a turn.
so now are you continuing with rotation or are you taking doubts?
Doubts.
Okay, sir.
Sir, theoretically, we know how to drive a car, sir.
so
Now,
sir,
Yes, sir.
sir on the
Once
board,
प्रैक्टिकली भी आता है.
practically, sir, ही सिखाएगा हमको.
Hey, practically मैं नहीं सिखाऊं. ड्राइविंग स्कूल
ड्राइवर
में
बने.
बैठाए क्या मुझे?
फिर चला तो हम सब आएंगे इतने सारे लोग हैं.
जेई के बाद
तो
कार्स
साइड
होगा तो ये
पे offline चाहिए.
होगा.
देखो 100 लोग दिए हैं.
क्या?
जब भी न्यू कार लेंगे तो ये सब फैक्टर याद.
सर आप फ्रिक्शन के लिए क्लॉकवाइज डायरेक्शन वापस दिखा सकते हो.
About the center of mass. Friction is acting
Yes,
this.
sir. Okay, sir. Got it.
Sir.
Sir, is the distance between the wheels in a double decker bus equal to that of the distance in a like a single best bus?
Not very different. They will almost be the same. Because they are meant for city roads. They occupy more bed, traffic